Good afternoon and what's up to you all awesome guys. I hope you enjoyed your day at school or you're still enjoying learning with us, because I know that some of you have been watching all our shows. It is a Wednesday of life sciences. So bring on your parents, tell them to come watch with us because it's all about life sciences. My name is Abram and today we are having the awesome, the beautiful BC, but CA today, Cheryl. How are you, Cheryl?
You know what, I'm waiting in anticipation. What are you going to call me today? Do they know what BC and CA means?
You tell them.
Okay, BC, before computer, and CA, Cheryl and Abram.
Of course. I think you love that one most.
I do. You actually, I do. Yes.
All right,
yeah.
cool. What are we doing today?
We're going to see how this works.
Okay.
All right, well, we can do all these things and think and whatnot. Yeah, so we're going to look at the brain and the spinal cord.
Right, talking about the brain, let's get thinking, guys. Send your questions through in your comments on our Facebook page, which is facebook.com/LearnExtraXTRA, or follow us on Twitter @LearnExtra. We've got an exciting show, guys. It's all about learning. We also have some competitions for you, so you don't want to miss anything on this show. Cheryl, I must mention that the notes that we're having for the mindsets are from the workbook. And the workbook is very affordable, only 139 Rand. Simply send an email to sales@mindset.co.za and we'll tell you more about it on how you can get it. But for now, because I'm a nice guy, I've already posted the notes for you, so get them or go to learn.mindset.co.za. Let's do this.
Sure, you can talk. On and on. Welcome. You say good afternoon. Isn't it good evening? It's like dark outside already. Yeah, I can feel the night time. Anyway, good evening, grade 12. Welcome to tonight's show. We finished our genetics section, which we've been doing the last couple of weeks. And tonight, can you hear my voice?
It's back.
Getting better. It's getting
nice
better.
One.
All right. And tonight, we're going to be looking at the central nervous system, the nervous system. All right. And we're going to be concentrating on the brain and the spinal cord. When you study this section, you're going to see sometimes your teachers might refer to it as coordination. All right, and those of you who say, you've got coords or whatever, that basically means that you can do the right thing at the right time. And that's exactly what we're going to talk about tonight. We're going to look, when we talk about coordination, all right, you need to know that things are happening outside, external, right, around your body, and things are happening inside all of the time. And you need to, all right, while your brain, your spinal cord, and a few other little bits and bobs, all right, need to make the right decision, need to make the right choices so that you can make the appropriate reaction, all right, at the time. So you are coordinated. We're going to be looking at two systems that we can sometimes tie together. Tonight we're going to look at the nervous system, right, the central nervous system particularly, which is going to be our brain and our spinal cord, and then we're going to look at the special sensors that are linked to it. You're going to look at a bit at the eye and the ear, and then you're going to have a different coordination system, which is a chemical coordination, and that is the endocrine system, or the hormones. Okay, so let's look quickly at why we need to be coordinated. If you have a look at the bullets over here, all right, what I've necessarily brought up to you, as I said before, things change, all right? Inside us, our environment, outside us, all right, our external environment, all right, we need to think, we need to remember, we need to, while we're sitting here, while I'm doing all my hand actions while I talk, all right, those are my voluntary movements. And while I'm here, maybe I had something to eat before I came, so my digestive system is working, okay, and hopefully I'm breathing. Okay, I don't have to think about those things. So there's certain involuntary things that are happening all the time, and those must be sent. Messages must come from the so-called brain and spinal cord. If you have a look at all right, just for the terminology, okay, there's two things I want you to be able to differentiate between our central nervous system. And when we talk about central, if we have a look at the diagram, that's exactly what it is, all right? It's in the middle of my body. So I'm going to look at the brain, my head is in the middle of my body, and leading from my brain is going to be the structure that we call the spinal cord, all right? Often we use the abbreviation CNS, central nervous system, that's fine. Central also means central control, all right? That means almost that most of the messages, they're really serious ones, are really going to come from here. So that's the central to the processing. Then leading from the brain and the spinal cord, if you see this word over here, peripheral. Peripheral means on the outside. Okay? So if you're on the periphery of something, as an English lesson tonight, you are on the outside of it. So what we need, the brain and the spinal cord, they need to get all of these messages, all right? And what do they need to do? They need to make an appropriate response. Okay? So when we look at the peripheral nervous system, you're going to see, you won't see them too much here. We need to have nerves that go towards our face, all our facial expressions, etc. And obviously, the rest of the nerves coming from our spinal cord that are going to go to all the different, all right, actions of the body. I want to just show you 5 little words that are very important, okay, that you need to know when we're going to look at it. Number 1, all right, is a stimulus. What does a stimulus mean? A stimulus, all right, is you being able, your environment, all right, changes. And that is a stimulus, all right? So, for example, let's talk about now. It's starting to become winter. How do we know that it's winter? Because the temperature outside has changed. So I need to know, all right, that it is getting colder outside because what will I do then? I need to keep my body temperature regulated. So I'm going to start putting on jerseys, etc. I'm going to putting scarves on so that I can keep myself warm. I'm not going to go running around. It's a scary thought in my bikini, which I don't have, right? But I'm not going to go running around with no clothes on and it's cold. Okay, it's not going to be healthy for me. So I need something needs to tell me, okay, it's getting cold outside. Let's try and adapt to the situation. That is your stimulus, okay? So that is your environment changes. Now, that change in the environment must be picked up. Okay, it's like your cell phone. Sorry. Like your cell phone is a receptor, a receiver. Okay? So what if a receptor, to recept something, all right, means to receive, to receive something. So what are we receiving here? A receptor means, okay, it's changed. I've picked up on that change. So a receptor is going to pick up on the change. So how do I know it's cold? Because I've got little special cells that are inside my skin that are going to tell me it is cold. All right. Now, what do we mean by a coordinator? All right. A coordinator means some kind of structure that is going to get or send the message to. All right. Say, for example, where's it going to send the message to? It's going to send the message to the brain, or it's going to send a message to the spinal cord, all right? And what is going to happen? Quite simply, a coordinator, I get the message. Now, if I get the message, what must I do to message? Okay, what do? Do I keep it to myself? No, all right? I've got to send the message on. I've got to do something about it. Okay. Let's do about. I need to write do something. There we go. Do something. I suppose I need to move, otherwise my arm makes it all funny. Okay, do something. Right? And the last thing is, when I do something, all right, I'm going to get a response. I'm going to get a response. Something, and we're going to do the something again because it could be so many things. Something is going to happen. Okay. And if you know those principles, those are going to be how we go. All right. Sure. It just gave me a fright. Did you see that? Hey?
Sorry.
I'm sorry. Did they know that the lights went out? Everybody, sorry. The lights went out, and then the lights went back on again, and I'm just unprepared. Sorry, it was a freaky moment. Okay. Now we calm, and we carry on. Okay. Now, when we have a look at these, you need to keep these things in mind when we start to look at certain actions. All right, let's go on to a diagram that and I'm going to do the diagram first. Grade 10, all right, in grade 10. I know you guys are thinking, I don't even remember what I did yesterday. Well, tough luck. We need to shake you up. You need to know. In grade 10, you did mammalian tissue. And one of the tissues you looked at was a nerve cell. Okay, now, it's called the nervous system. What does the nervous system mean? It means that any single time I get a message, okay, anything that happens, the message that I get, or the message that I'm going to send out, the way I'm going to do it is by using my nerves, using a nerve impulse. Okay, can you remember from grade 10? I want you to look at two specific nerves, okay? Sorry. One is what we call the motor neuron. Remember, a cell is called a neuron. So over here, this one is called a motor. Now, another word for it is multi. Now, have a look. We've got all these little branches sticking out. What are they? They're antenna. Okay, and what's going to happen? We're going to hear about this thing called an impulse. All right, and what is an impulse? An impulse is electrical current that we are going to transfer the whole way down this neuron. Okay, and that's one of the things you need to know, become aware of, is when we talk about the nervous system, how do we get the messages? Because that's basically it about. This coordination means getting messages to one place and from another all correctly. How do we do that? We do it by a nerve impulse. When we look at the endocrine system, the message is going to be sent via a hormone. Okay, so this is a motor neuron. Okay, now let's go what we did just now. Motor means to do something. Okay, so let's think. To do something. Right, so I need to do. But before I need to do, okay, I need to be able to sense something. Now, if you have a look here, you need to understand that the basic structures of these two are different. Uni means one. Do you see here? What do we have over here? We have the direction. We have one. Okay, sorry, my arrow's the wrong way there. We have got one little pole. We call this the axon. All right, can you see here? We've got one, the dendrites are at the end, but can you see where we've got, right, many points coming in? Here when I've got my sensory, it is one axon, uni, all right? And the cell body is outside. So if I were to draw it simply, all right, I would always draw it looking like that, okay? Looking like that. Where is the motor neuron? I would always look like a stick man on a very bad hair day. You don't have to draw anything too elaborate. So you need to know the difference. Sensory means to pick up the stimulus. All right, let's go back to my feeling cold. How do I know I'm cold? One, I need to sense that I'm cold. Then I need to do something about it. And those of you who've been cold, we start to shiver, all right? We got goosebumps. So our body starts to do things in response to being able to this change in the environment. So you need to know a motor neuron or a multipolar stick to motor. It's nice and easy to remember. Or a sensory neuron. One senses. So usually a sensory neuron goes to the brain or the spinal cord, and my motor neuron comes from. Okay, one must go to give the message, and then I need to get my answer back. Okay, when we look at the nerve impulse, I'm sorry, it was supposed to be an animation, but I didn't get it quite right here. You don't have to understand the whole process of it, okay? But when a message is sent, it's sent two ways. Firstly, all right, and this looks very confusing. Don't worry too much about it. This is the axon, okay? And when a message gets sent, sodium and potassium change the polarity of my neuron. In other words, it will go, as it goes along, we change. So they move out. So one, what positive, then negative, positive, negative, and as it go, an electrical impulse. Okay, like you know when you switch on the kettle, right? And there's the cord, and it's going across. Okay, so it's electrical. Now it's going across, and now. When we come to the end, I want you to have a look here. Have a look at this one. All right, this is the end over here. When I come to the end, when two neurons, or a neuron and a muscle and a neuron and a gland, they never, ever, ever join. There's always a gap, all right? There's always a gap. And that gap, we see, look here, right? That gap over here is called a synapse. All right, now we have a problem because electricity cannot jump from one side to the other. So we need to send our messages differently. Okay, how do I do it? Now I need to change. Now electrical, 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 electrical. What do I do when I get here? At the end, I've got these little bags of chemicals, all right? And imagine if electricity hits you, oh, you run away, okay? You've been hit, you get shocked, and you move. And what do is now, this is a bridge. You need to go across the bridge. All right? And that little thing is called a neurotransmitter. I think we've reached the end of our time. Hey, Abram.
Yes, we have.
I can feel that glare you're giving me through my back there. It's time.
Need a break.
Yeah. Well, I'm not going to say my bum. Yeah.
Well, guys, thank you for staying tuned with us. Watch this, and I'll tell you more about it when we come back from the break. Welcome back, awesome guys. Now, if you are intending on studying at any higher institution of learning next year or tertiary, you need to register right now by simply filling in a form, and then your name gets to be added on our database, and you could win yourself 1 year of free accommodation at any South Point next to the campus where you are intending to study at. More details are on our Facebook page. Go to facebook.com/learnextra. Now, Cheryl, I've got an interesting comment here.
Oh, you always scare me because you always make me unprepared.
No, it's not a question.
It's comments, okay.
It's just a comment.
Okay, oh.
No, you're going to love this one.
Okay.
Sandy Da Silva says, I've just downloaded my notes. I'm studying with you. It is funny that at K Science School, we are done with the whole year's work. So now it's revision. Hot you guys.
Sure.
So they are done.
They're done, but how well did they do it?
I don't know. The whole year's work.
Yeah, what are they going to do now? Revision, you say?
Revision.
You can only do so much revision, poor them.
Maybe you should give us some tricks on how did they do this.
Yeah, because then we could only have 6 months of school, and then the rest of the time we could have holiday. Yeah, but we're not going to go there.
Very interesting.
Okay. The science teachers would be banging on your door going, no, no, no.
So you better use this time more effectively.
Yeah, listen to us, and we can maybe help you, maybe learn something that you haven't learned.
Of course.
Okay. All right.
Let's continue.
Okay, I'm going to quickly just end off a little bit where I did last time about these neurotransmitters. Okay, so we just said the nerve impulse, because we're going to link it to something that we're not going to talk too much about tonight, but you must keep aware of, okay? When this impulse comes, jumps. So we change from an electrical, all right, to a chemical. All right, stimulus, and guess what? Then we go back to electrical again, okay, if it's another nerve. Now, that is called, those are called, chemicals are called neurotransmitters. Neuro, like neurons, transmit to carry a message. When you look at your session on drugs and alcohol, all right, they interfere with how the message gets across. So when you drink too much, all right, these messages do not get across as they should, and that's why you become uncoordinated. Okay, all right, now let's look at the brain. When you look at the brain, first thing you need to look at, okay, is how is the brain protected. So the first thing, when we look at our brain and spinal cord, you're now going to go back to, all right, guess what? The grade 10 syllabus again, where you did the skeleton. Okay, brain and spinal cord, very, very important. So it would be obvious that we would protect them as much as we can. Okay, I want you to have a look at how we're going to protect the the brain, okay, and also continuing into the spinal cord. But we'll look at the brain first, because we're going to start off with the brain. If you have a look over here, all right, let's look at this little dude over here with the face. The first thing that we're going to notice is the skeleton, all right? The skeletal system was bone, and what do we see surrounding the bone? We are going to have, on the outside here, we are going to have the bones of the skull. All right, so the very first layer is the hard layer. Now, here is the brain, and here is the skull. Now, when it comes to from the brain to the skull, you need to understand that it's very dangerous if the brain rattles around in the skull, okay? Very often you hear on the news where somebody, it's called the shaking infant syndrome, right? When they shake a child, right? And that when you get so angry and you shake it and their head goes back like that, what actually happens is their brain, right, bashes against, all right, their skull because they're still developing. And you should know, it's a tissue. What's going to happen? It's going to bruise and it's going to swell. And because the brain is so enclosed in the skull, the brain has got nowhere to swell. Okay, so when it does swell, the pressure on the brain can cause damage and even death. Okay, so what we need is, we need the brain to have a slight bit of movement, right? But we also need the brain to be quite well protected. So what we have is, right, is these three layers. We've got one on the outside, right underneath the skull, right? And that is called the dura mater, right? And what dura means is tough, okay? And what mater means is mother. So remember, guys, it's Mother's Day this Sunday. Don't forget. My family as well. Don't forget. Okay. Note to self. All right. So dura means tough. We talked about in grade 10 again when we did the tissues. We spoke about this tough outer fibrous layer. So we've got underneath the skull, we've got this tough layer as well. On top of the brain, okay, if you have a look over here, there's a thin layer. Let me use a different color quickly. I don't know if the yellow looks better. There's a thin layer on the surface of the brain, okay? And that is pia mater, and pia actually means delicate, okay? So that means delicate, means soft. You don't want anything too hard. In between the two layers, all right, you are then, I don't think you can actually see that, you are going to have the layer called the arachnoid, all right? And that arachnoid is filled with fluid, it is filled with blood, and that basically nourishes all the membranes of the brain. When you put those three together, we have, let me go over here so you can see, right? What we do is we call these the meninges, right? Those three layers are called the meninges. Now, those of you who have heard of sometimes a viral or a bacterial infection called meningitis, right? That is when the layers of the brain, right, are affected and they swell and they cause the swelling on the brain, all right? Meningitis, not a very, very good thing to have. Okay, now let's look at the structure of the brain. When we look at the structure of the brain, what I need you to do, I need you to take a piece of paper, all right, and I want you to draw it, and I want you to color code it. When it comes to the brain, what you need to have is you need to have a picture of what the brain looks like on the outside, and then you need to be able to adapt it if I took my brain, okay, and cut it, transverse section. In other words, I take it and I cut myself in half. Then I turn around and you're looking at the inside of my brain. You need to be able to see what the internal structure looks like as well, because there are a few things inside that we need to look at that we don't see on the outside. Okay, so let's start off with the brain. When we look at the brain, what you need to know is you need to be able to identify a diagram. If we don't get to the diagrams or the practice questions, I hope we do, all right? Please go and have a look at the kind of questions. They are related to, they are usually, I find them to be quite easy study questions. In other words, label this part of the brain. What is it? What is its function? Okay, and that is very simple, easy notes. So if we have a look here, and I'm going to show you two diagrams, this is what the brain looks like on the outside, okay, the external structure. And what we see is, we call these lobes, all right? So when we look at the brain, the biggest part of the brain is this large lobe over here. Okay, now I want to show you, and this is why I put in this diagram at the bottom here. When we look at the different lobes, right, you're going to find this big part of the brain. And this big part of the brain with all the colors, all right, is called, I'm going to go back to pink, it's nicer, is called your cerebrum. All right, don't get confused because we're going to get the cerebellum. Okay, now all of this, okay, that I've done is called the cerebrum. It's the big, big part. And those of you, when you're going to be doing the evolution, you're going to notice that this part is so much bigger than when you look at the chimpanzee, and you're going to hear a word called Australopithecus later, why we are so more intelligent, etc. Okay, so now these big lobes, and we have two of them. And I'm going to show you the internal structure just now. We join them together, all right? We join them together. But let's just concentrate on this big lobe called the cerebrum. If you notice, these little lines are convolutions. What does convolution mean? They're folds. And what do we know about folds? Folds let us increase the surface area. Okay, so we've got more brain cells to do more things. Now, we divide the cerebrum into the different lobes, okay? And if you have a look at the diagram below here, all right, don't worry too much about the other ones. If we look at the parietal, the occipital, the frontal, and the temporal, they all have particular functions. Now, if you have a look at the name of them, you should be familiar with them. The reason being, you, in grade 10, when you did the skeleton, you would have labeled, all right, that parietal bone. You would have labeled the temporal bone, occipital bone. So the bones of the skull actually, all right, are called, mirrored over the same bones of the brain, the lobes of the brain. Okay, so now you need to draw something like that. You can draw it. It's easy. You must be able to draw it. Guys, when we draw the brain, okay, we have a little stalk, we have a little bump, and then we just have this big cerebrum. Okay, doesn't have to be an artist. You just need to know it's big. And what is this one? What is the cerebrum? Now we know the cerebrum. What must you do? You draw a line, okay? And from the line, you tell me all of the things that the cerebrum, all right, is capable of doing. What are the functions? There are many of them, okay? But I would concentrate on at least the two most important that I would concentrate on are as follows, okay? They would be, let's have a look over here. At the back over here, if you notice, look, have a look. Vision, okay? Over here, language, vision, speech, hearing. So what you will notice is, all right, all of these, number one, our senses. All right, all our senses are located in my cerebrum. Okay, number two, and this is also important. Okay, let me find where we're going to get. There we go. All right, perception of an object. Okay, knowledge of numbers, thinking, behavioral emotions, language recognition, vision, hearing, emotion. Also, voluntary muscles. Very important. All right, because if I want to do this, if I want to scratch my nose, if I want anything that I choose to do, my voluntary actions, my voluntary muscles is going to come from my cerebrum. Then I have a little acronym that I always, if you want more functions, right? I talk about something called MERWIC, M-E-R-W-I-C. And what MERWIC is this is what makes us different to any others. Because what else can the cerebrum do? We have a memory, we have emotions, we can reason, we have wisdom, all right? We have intelligence, and wisdom and intelligence are not the same thing. And then the one that I always never can spell, all right, is our conscience. What is our conscience? The ability to tell between the good and what's bad, right? What is right and which is wrong. Okay, so there we go. We've got a diagram. What do we know? We add all the functions of the cerebrum. So I have my cerebrum, and I know, all right, exactly where the functions are. This one I always love telling the kids, because right over here is where you see. So I always say to them, you see, guys, you do have eyes, as your mother says, in the back of your head, all right, because that is where you're going to see. Now let's look at it. All right, and let me go back here again. Now if we have a look at the brain, I'm going to go to this diagram. We have this little structure at the bottom. All right, now when we look at it, I'm going to show you this diagram over here is what the internal structure of the brain is. So we know that nice big globe, all right, what is that going to be? My cerebrum. Okay, and here's my corpus callosum. That's what holds my two brains together, right, my two halves. Now let's look at this little interesting one over here. It's at the bottom. Now, very often you get confused between the spelling of cerebrum and cerebellum. Okay, now this little guy is very important when it comes to my ear. Okay, because what this guy does, now I always say to my kids, if you have a look, cerebellum has got two lines over it. They're parallel lines. And if you want to walk on them, you have to have good balance. All right? And that is what your cerebellum is going to do. It's linked to your ear, and you're going to see in a couple of weeks when they do the ear. Your balance, all right, is where, all right, you're going to perceive here. Being able to walk, all right, so if I want to fall, what will happen? If I don't fall, my muscles are going to get tight, and then I'm not going to fall. So we talk about muscle tone, but my cerebellum, all right, has got to do, let's go over here. Okay, you'll see, it says here, coordination, hand-eye coordination, balance. Okay, again, being able to do things coordinatedly. I know that's not a word, but it sounds good. There's the two L's. The two L's, balance. And what are you going to remember? Your ear, all right? The structure of your ear. Then when we come to our brain, all right, then we get to this very primitive structure called the brain stem or the medulla oblongata. Okay, medulla oblongata. And what the medulla oblongata does, if you have a look at the functions, all right, it's pretty much the function that any animal, if I could say the word, has. Okay. It regulates your body temperature, your heart rate. If you can remember in grade 10, your heart does not need a nerve impulse to beat. Remember you spoke about the pacemaker. However, how fast or how slow your heart beats is going to go from the medulla. Also here, have a look, your breathing. Okay, your breathing. The brain controls your breathing. So very often, sometimes when you watch some of these doctors' program, they say to you that somebody is brain dead, all right? And what do they mean by that is, and they'll put them on machines. And what they mean by that is that if you are brain dead, they put you on machines to help you breathe. But because the heart is not connected to the brain, so to speak, to function, the heart is still beating, all right? So technically, you're not dead, so to speak. Okay, so that's what happens when they say you are brain dead, all right? They put the mask to help you breathe, because you can't breathe, because breathing comes from the medulla. But the heart rate itself, it's got its own pulse. Remember, you did the pacemaker when in grade 10. You see how grade 10 keeps popping up tonight. Okay, all right. Now, if I were to look inside, so it's a different concept. What would I find? There we go. There's my cerebellum. Here is my medulla oblongata. Okay. Now, what I can't see, all right, on the outside is this little part of the brain over here. Okay. When you do the endocrine, you are going to hear a lot about a little gland called the pituitary gland, all right? And the pituitary gland, I'm going to show you another diagram of how your notes could possibly look. The pituitary gland is over here, right? And around from the pituitary gland over there is the hypothalamus, okay? The hypothalamus. And the hypothalamus, if we have a look, go back here, all right? The hypothalamus is going to control how this little gland does its work. What the hypothalamus also does is temperature control. And why am I concentrating on that? You guys are going to look at a section called homeostasis later. And when we talk about homeostasis, you are going to see how does your body control when it's too hot or when it is too cold. Okay, so what you should have now, if you can, you've got a nice big piece of paper and you've drawn here, look here. These are the kind of pictures you've had. You've drawn a simple structure of the brain. You have labeled each of the different lobes. You've labeled each of the different parts of the brain, okay? And you have put the functions next to each of them. And then you draw another. It doesn't have to be, and if you can't draw, then you can trace, all right? Then you look at the inside of the brain, okay? The internal, a transverse section. So I'm cutting myself in half, and this is what I see, because there's some bits that I can see inside that I can't see on the outside. We're going to stop there, because then I'm going to start with the spinal cord just after the break.
And I've got a lot of questions for you.
Holy cow.
And a lot of comments for you. But talking about comments, I'm not sure if it's I'm not sure if it's a coincidence, but I think it's well planned.
Yeah?
It's like me and you on this
It's
magazine.
me and you again.
So guys,
CNA.
guys, it's a CA,
CA thing, yeah.
It's a CA thing. Me and Cheryl are on the U magazine. So guys, you should get yourself this copy and check out. Mindset is doing it, guys. Learn extra. So do check out our article. It's on page 83. So get yourself this copy.
My mom bought it. She's
Otherwise,
so proud.
Your mom bought
My
it.
mom,
I also
bought
bought
it.
it. My friends bought it as well. So if you bought it as well, send us a picture and let me know. And I might put up your picture on our Facebook page. But otherwise, I'll see you after the break. Welcome back. If you think you are a bright spark, enter the Be a Bright Spark competition and you could win yourself that cool Chevy Spark L, just like Dumakato, our very first winner. So 3 more cars to be given away and 1 could be yours. All you need to do is to purchase the Surface 353 manual or download the Cool Android app, which is available from Samsung Galaxy App Store or the Google Play Store for only 59 rands, guys. And then jump onto our Facebook page, like it, and then fill in the entry form. Winning is so easy. Imagine winning a car, Cheryl. I so need it.
It would solve a lot of my issues. Yeah.
Well, the nice
Financial
part is you
issues.
can't win. That's
I know,
the nice
you've told
part.
me that nearly every single
Oh,
show.
okay.
And I've reminded you that neither can you.
All right.
So back
Well,
at you.
you can win. Enter right now. More details on our Facebook page, facebook.com/Learn Extra. Over to you.
Are we back? Okay. Abram says we've got lots of questions that he wants to ask me. So I'm going to go through the questions, but I want to go through just 1 or 2 things quickly for you. And that is we're going to jump to the spinal cord, all right? And when we look at the spinal cord, this is the picture that you need to become familiar with. Now, just as what you are looking at, when I look at that, I'm like, what on earth am I looking at? All right. So here is my spinal cord. It is something round. Unlike my brain, which has got a right and a left side, and I can cut it in half, I can't cut my spinal cord in half because it's round, so I've got to look at it like it's a cake, okay? So now imagine here's my spinal cord, and I cut it this way, all right? And now I turn down, and I make it, and I'm looking at it from a bird's eye view. This is what my spinal cord is going to look at. Okay, Abram, I'm going to use yellow. One of our viewers says he doesn't like pink. He would like me to use yellow this year. Okay, just a little bit of personal information. I hate yellow. The only thing that should be yellow is flowers. But for you, I have no idea what the person's name is. What's his name? You say?
Lindo Guse.
I told you earlier, me and the names. Okay, I will use yellow for you. All that you need to know, have a look over here, all right? this is my spinal cord. And now the words that are confusing for you, I think, are dorsal and ventral. All right. Now, what does dorsal mean? Think of a fish. A dorsal fin is found on its back. Okay. So if I was to stand like this and you were to chop me in half, right, and look down at my spinal cord, this would be the back, all right, and this would be the front. Right, so back is dorsal and front is ventral. Okay, now my spinal cord has got this hole in the middle because in my brain as well, I've got this fluid called all right, cerebrospinal fluid, CSF, that is floating, all right, keeping all it's nourished, lots of things happening there, right, floating through my brain, all the pathogens, etc., can be found in there. Now, what am I looking at? Remember what I said to you, okay? I get messages from the receptors. So let's look in my skin. I know it's cold. So what do I need to do? I need a nerve to come into my spinal cord, all right? And what would generally happen? It would then travel up my spinal cord to the brain. Then the brain makes a decision. And what comes back down again? The message comes back down. And what do I need to do? I then need to send the message out again. Okay, so can you see where these little arms come? It looks so bright in the yellow. Okay, I'll stick to yellow with a dash of pink every now and then. Okay, so now what we have, if you're looking at, remember, here I want to know it's cold. So in comes the nerve, goes to my spinal cord, goes up to my brain. My brain says, okay, I know it's cold. You need to shiver, get goosebumps. Your hair needs to stand on end. You mustn't sweat, but we'll get to all those things later. So it sends a little message back. Dung, 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 dung. This is what you must do. Okay, now, did you notice it's got to go through the spinal cord, up to the brain, and back down again? What happens if you need to make a quick decision? This is a diagram you need to know, right? This is called a reflex arc. A reflex arc. And this is when a decision, all right, to do something needs to happen so quickly. And when we can do that, we need to cut out the brain. Yes, the pain might come later, right? But we use, like, if I step on a thorn, if I put my hand on a hot plate, what do I want to do? All right, I want it to be instantaneous. I want it to be quick as possible. Now, that's what's going to happen. Now, when you do this thing, I want to just quickly show you. Have a look quickly over here. All right, if you can see the questions on the structure of the spinal cord. Here is the reflex arc. All right, and even here is a question on the reflex arc. So it's a nice popular question which we can ask. Okay, now, what is it? As I said to you, it's a quick way in which my body can respond. Now, when it comes to the reflex arc, there are 5 things that you need to know. Okay, number 1, let's go back to the beginning. I put my hand on a hot stove. Let's see over here. Here, this is a pin, okay? I put my hand down, and there's a pin on the surface, okay? I'm not going to go, ooh, that's so nice, it's so sore. What am I going to do? I'm going to go, ouch, okay? It's going to be quick. So what happens there? First of all, in my skin are my receptor. And what does a receptor mean? It picks up that I have been stuck by my pin. So number 1 is a receptor. Receptor means receives the message. Now, number 2, which you need to be able to draw nice and easily, is I need to sense that I, have put my hand onto the pin. And that is my sensory neuron. Okay. Now I need to do something, but this is where things just get. I don't know if any of you need an interconnecting flight. We are going overseas. I never go overseas. Can't afford it. Right, let's say you're going to Cape Town, and what you do is you're going to have a stopover. That's exactly what happens. The nerve goes, and then what do we see here? In the spinal cord itself, we have what is called an interneuron. You might call it an interneuron. Some call it a connector neuron, all right? But what happens is it takes the message from the sensory to the motor. Now, I know that it's sore, but what do I need to do? I need to do something, all right? I need to bring about a response. What brings about a response? Okay, number 4, a motor neuron.
I
Okay,
think sure you can use your pink there.
oh, can I use my pink now? You
White
know
and
what?
pink.
No, white and pink. James, you must decide it's either pink or it's a black and yellow and white and pink. Is that the rules?
Yes.
Okay. Oh, there we go. Here's my motor neuron. The message goes do-do-do-do-do, and it goes to my effector. Effector means I am going to do something. It brings about an effect. All right, an effect. All right, there we go. No, it's very simple. Label 1 receptor, 2 sensory, 3 interneuron, 4 motor neuron, 5 effector organ. Hit it.
I'm ready. So many guys are watching the show with their moms. Kolani Sandlana says, I'm watching the show with my mom. Big shout out to you and your mom. Also, with Dumelo Mpali, today I'm watching with my mom. How great, love the show. Thank you, guys. Let's get to questions.
Okay.
Why is this? Right, first one is from Emily. Which part contains vital centers that control heartbeat, respiration, and blood pressure?
Sarah, which one? Heart rate? Heart?
Which part contains vital centers that control heartbeat, respiration, and blood pressure?
The medulla oblongata. All right. If you have a look at the brain, one thing, the brain stem, nearly all animals, so to speak, have a brain stem. All right, and that means those are functions that all living organisms need to do. So that's what we call the vital, being able to, our reflex actions, blinking, swallowing, breathing, our heart rate, our blood pressure, etc. Those are the vital centers, and that is your medulla oblongata or your brain stem. Because it's simple, you see, everybody needs to do it. So we all have it, and it's a simple part of the brain.
Okay. Right. Lushohonono Jomo Libya says, what is the rapid automatic response to an external stimulus?
What is that?
What is a rapid
Impulse.
automatic response?
Impulse. An impulse. All right. Or sometimes what he wants is a reflex. Okay. A reflex action. So in other words, if I were to go to you now and I would do that, what did you do? You blinked.
I blinked.
Okay, because I came to your eyes, so you want to protect your eyes, you blink. All right. Maybe if I came with you at your fist, what would you do? Okay. When you choke, what do you start doing? You try to cough. All right. Because that is a reflex action. So if you feel that you're in danger, all right, you're going to have a
when the lights
action.
come on.
Or when the lights come on, then you go, like a girl. Yes. Yes.
All right. Lloyd Plan says, I'm enjoying the show with my brother and keeps telling me about the spinal cord, and he's only 6. How cute.
Awesome.
All right.
Never too young to learn, hey?
Yeah. The younger, the better. They learn more. Mano Madzinga says, are sensory neurons present in the spinal cord, or we only have the connector neuron on the inside?
Only inside is the connector neuron. All right. My sensory neurons are my peripheral neurons that are on the outside.
Okay. More questions for you. This one is from. Sorry, when technology fails you. Muzi Godfrey Koza says, what is the difference between reception and perception? Reception to receive something. Perception is something totally different. How you perceive something. Okay, I must look into the camera. Reception means you get this impulse. You receive something. Okay. Now your perception is your take on the situation. And that is not something that is, all right, a simple physiology. That is something that is
also emotional. So perception, what are your perceptions about things? Okay, so your perception is, it could be biased, all right? Is your perception, maybe you've been abused or something, then maybe you might be scared of certain situations than others. Do you understand? So perception is how you see something in that particular moment. This is not it. That's a psychological thing, all right? Reception, your receptor, all right, is something that gets a message, and then we must make a response. Okay.
Right. Tepiso Tato says, how does the brain control the heart and things like the formation of urine?
Okay, all right. Okay, let's go there. The brain does not affect how the heart beats. If you go back to grade 10, let me quickly go over here. You guys, when you go back to the heart, all right, I know this is not what the heart looks like. You had that little node called your SA node, and it's made up of a nerve impulse, right? So when it starts, it's made up of, it starts by itself, all right? So now what happens? Stimulus goes out, my atria contract. There's another little node here. What happens? The stimulus goes out and the bottom contracts, and my heart goes back together again. But now I'll go for a jog, okay? And now what happens is, what happens to my heartbeat? What do I need to do? My heart needs to beat faster. Why? I'm using up oxygen. I need to get all that oxygen to my muscles. So the faster I run, the faster my heart beats, the faster I can get the oxygen to my muscles. Okay? That is rate. So that is different to the heartbeat. All right? That is different to the heartbeat. Okay, so just remember, heartbeat, heart does itself. How fast or how slow, that's the brain. Because if I'm running fast, what am I also doing? I'm breathing fast, okay, and my brain is telling me, oh, you need more oxygen, come. Okay.
Comment from Nwape. Nwape is a big fan of yours, hey? You remember, from Zambia.
Oh, he's a Zambian,
yes,
okay.
He said today, wow, I enjoy your teaching. I think you are a good teacher from Nwape Chisanga in Rayton Town Center, Ndola, Zambia.
That name is awesome. Thank you.
Right. Right, another question. Tandega Masuku says, when a person collapses, does the mind or the spinal cord fail?
Nothing fails, right? When a person collapses, all depends on what. Say, for example, you haven't eaten today, all right? You haven't had breakfast. What happens is when you're standing, or if you haven't had food or you're standing for a very long time, all your blood, not all of it, it goes down into your legs. And you're not getting enough blood to your head, okay? And what do we need? We need lots and lots of blood to my head. So what happens if I collapse? I fall on the floor. Now when I fall on the floor, where's my head and my legs? Like this. So what does the blood do? It rushes, and it rushes to my head, all right? And that's a form of me getting back the blood to the head, all right? If I haven't eaten and my blood pressure is low. Well, depends, I said, the collapse, yeah. If it's a seizure, that's something different. That's when a brain has a fit. That's epilepsy, yeah.
Okay,
are we finished?
We done. Thank you so much, Cheryl.
Thank you, Abram.
And on that ending note, Leto says, hi, Abram, I'm watching the show with my dad. So perhaps you and your dad, for the first time, we've got someone watching with his dad. Thank you so much, Cheryl.
Thank you.
And thank you guys for watching our show. It's been a great evening spending together. And a big thank you to the Department of Basic Education for making this show proudly to us. So we thank you guys. Have a blessed evening. Peace.